Good afternoon, everybody, and welcome to April's Global Health Compound Design webinar. I hope you're all sitting comfortably. It's my pleasure to introduce today's speaker, who is Mark Gardner from AMG Consultants. AMG has been running for about the past 6 years, and prior to that, Mark had extensive experience of developing drugs at Pfizer, and he's going to talk to you today about the PK solver Excel-add-in as a way of pre-processing data for the free BMGF-funded PK tool. The first thing that you can see on your screen is a quick poll. So if you could give an answer to that, we'll just give everybody a couple of minutes to have a look at that and click on one of the answers. Okay, right, so I'm now going to close the poll. Ooh, and there we go, here are the results. So that's exactly what we wanted to see this afternoon. So the majority of people online are of the yes occasionally or yes frequently classes. So, okay, I'll hand the floor over to Mark, who's going to present the webinar.
Great, thanks very much, Caroline, and good afternoon, good morning, everybody. So I'm going to talk about the PK solver, and I'm going to give you a little bit of background about how it fits in with the PK tool as well, which we had developed a couple of years ago, that some of you may be aware of. Give you a little bit of background about the solver tool itself, and then go through three use cases in some detail, a little bit more further information, and then at the end I'd like to just go over where we are with the PK tool itself and some proposed enhancements with that. So at the moment, if you're new to these webinars, you won't be able to speak, but please feel free to put questions or chat in the appropriate boxes, and we'll try and get to those. And when we do have questions at the end, you can raise your hand, I think, electronically, and we'll try to answer those. Okay, so in terms of where the PK solver fits in to what we're trying to do, the PK tool was commissioned a couple of years ago because some of the people that we were talking to at MMV and DNDi and TB Alliance were suggesting that it would be nice for people to have a tool to make human dose predictions. We were after a relatively simple tool because we were thinking of application in the discovery setting rather than in later development, where probably more sophisticated tools, dare I say, driven by perhaps more expert people, would probably be appropriate. And so the PK tool was born, and that's really aimed at prediction of human pharmacokinetics and dose, and it uses allometry or in vitro experiments to estimate clearance. And there are other webinars in this series devoted to that, and I'm going to come back to it just to talk about some of the enhancements at the end. In terms of where PK solver fits in, so one of the things that we discussed when we were looking at enhancements to the PK tool itself was that currently the PK tool doesn't offer a way to go from a set of raw pharmacokinetic data to the calculation of PK or estimation of PK parameters. And that's what we thought would be interesting to access. But looking around on the web, it became apparent that the PK solver actually addresses that need quite nicely. So at the moment, we're not proposing to include this functionality in the PK tool, but to point you in the direction of the PK solver instead, which is what this webinar is about. So I'm going to talk about some use cases. We're going to talk about calculating PK parameters. So, for example, if they're not provided by a CRO, if you've had your PK experiments done that way, it's obviously useful as a check if the PK parameters from the provider look a bit surprising. So I'm going to talk about comparing the results you might calculate using the PK solver with ones you might get, and that's I'll use an example from a CRO I've worked with to exemplify that. And also, one of the nice things about the solver, it's an Excel add-in, and it provides some functions that you can use in Excel. So you are able to calculate PK parameters in a kind of batch sense using spreadsheet functionality if you want to. Okay, so the PK solver was actually published several years ago now, 2010, and this is the original paper, and there's quite a bit of information in there about how it works. It's been pretty well cited since then, so this is citations by year, just dug out of Google Scholar, and from what I could see when I was looking online, it was far and away the best, most used kind of free tool for doing this. I should say I have tried to contact the authors, but I've been unsuccessful. I think at least one of them may have moved on organization. But anyway, fortunately, the solver is still available and still works. In terms of installation, I downloaded it by following the links here. So this is a list of various software that you might be interested in. Within it, this link to the zip file contains both the Excel add-in and installation notes for PC and Mac on various Windows versions. So you get the XLA and the installation notes from that zip file. So it's written in Visual Basic. It's an Excel add-in, and as I mentioned, it nicely complements the PK tool, which assumes that you have PK parameters available, whereas the PK solver is about calculating those parameters from raw plasma concentration time profiles. So just in terms of a quick overview, once you've installed the add-in, you get the menu option. There are several menu items underneath this, so choose the one that you want. We'll come back to that in a minute. Then you get a panel come up into which you put your time series and your concentration, and then some information about the experiment in terms of units and dose and things like that. And then there are some further options. You basically then hit run, and you get a separate spreadsheet with a bunch of calculated properties, calculated parameters, and 3 graphs in there. So I'm going to start with an example using IV data. So I've been using the non-compartmental analysis, the bolus, intravenous injection version. There are other options which go into compartmental analysis and things like that. So this is a list of some raw data that I've got. So the time course and then concentration in nanograms per mil. And so you just fill in the appropriate, click on the time box, and then just drag down through the time panel, and the same with the concentration. Put in the time units, concentration units, those units, hit run, and you get this output. So a bunch of titles reminding you what choices you'd made, the parameters, the raw data, and 3 graphs, so that you get a concentration time plot. You get the same thing but in a log concentration, and then the final panel shows the points used to calculate the terminal slope. So in a bit more detail, this is the title, and you get your data repeated, and then also it shows you the natural log of the concentration and the AUC using a trapezoidal method. And we'll come back to that in a minute because there are some options about how you do that calculation. Then there's some other parameters here, which I'm not going to go into too much detail about. There is more information in the paper and the installation notes. And then these are the three graphs. I've just overlaid them on top of each other. So just the simple concentration time plot, the same thing logged. And then this final one is the same thing, but now picking out the data points that have been used to calculate the terminal slope. You can see in this case, the tool has chosen 3 points. There's some options around that. It actually uses at least 3 points in calculating the terminal slope. Then the parameters, this is a blown up version of the parameters that you get. There are more parameters available. If this list isn't enough for you, there is a button under the options tab to generate a list that's about twice as long as this. The units will depend on the input units. So you can see in terms of clearance, the concentration values I had were in nanograms per mil, the dose was in mgs per kg, and the time was in hours. So that's the units that are used in the clearance. It's not, doesn't necessarily give rise to the most intuitive size of value. So you may want to use different units if you would prefer to see this in a different on a different scale, or you can obviously do the calculation. In terms of comparison with CRO values, so for this compound, the values that I got from PK Solver are shown in this the value column here, and the CRO value in the same units where I've had to transform them here, and then I've got a final column which is just showing how those two relate to one another. And you can see that at least for some of them, they're very close or exactly the same. Those that I've highlighted in orange are at least slightly different. And the reason for that turns out to be that whilst the PK Solver has used the final 3 points in calculating the terminal slope, the CRO used only the final 2 points in calculating the terminal slope. So as a check on that, to calculate the terminal half-life, the half-life from just the last 2 points, we can use this equation, and then you get a half-life of 5.61 hours, which is the same as the CRO's value. And in fact, although the PK Solver requires that at least 3 points are involved in the generation of the terminal slope, you can kind of trick the tool into doing that if you add an extra time point. You can't duplicate the time points, it will throw an error, but you can do very close to duplication, as you can see here. So now in the final graph of the 3 that you get output, you can see that the PK Solver is now it's actually using 3 time points, but of course these 2 are on top of each other, and so the values that you get are now exactly the same as those in the as the CRO. So you can see these in the columns here are exactly the same as those of the CRO, so we've got identical values. Just a little bit more about some of the options that you can use within the add-in. So in terms of calculation of AUC, I hinted at this earlier, so you can imagine doing that using calculating the AUC. It's usually done with the trapezoidal method, and you can do that with linear or log linear, and a method that's often used is linear for the increasing part of the curve and log for the decreasing part of the curve. And that does make some difference in some cases. You can see in this case, actually, it changes the AUC from 0 to T from 1268 to 1161, so it's a 9% difference. So it's not massive in the terms of usual biological variation, but it does have some material impact. You can also force the PK Solver to use a particular number of points to calculate the terminal slope, or let it decide based on the points that are presented. Another nice feature, if you click the output button here, you can generate a Word document if you want to. And as I mentioned, if you click this radio button here, you'll get a longer list of calculated parameters. The point about linear up and log down, I think it's been much discussed in the area, but there's some nice descriptions, a video and a web page from Nathan Teuscher of Satara, who's gone into that in some detail. In terms of oral dose, and bioavailability calculation, the PK Solver tool, obviously it analyzes one concentration time plot at a time, and obviously bioavailability requires a comparison between IV dosing and your other method, often oral, of course. And so in order to calculate bioavailability, you're going to need to run the PK Solver twice on both the IV and the oral dose, and then do some simple maths. So I'll just demonstrate that. This is the oral dose for the same compound I demonstrated earlier. The dose is different. So this dose is 2.5 mg per kg. This is the set of data. Actually, it's one time point fewer. I've also should indicate that now we're using the extravascular mode in non-compartmental analysis to do the calculations. So these are the three graphs that you get, and now this is the familiar time course where, of course, you get no plasma concentration at time 0 and reaches a peak here at 2 hours, and then decreases as before. You can see this time that in the calculation of the terminal slope, the last 3 points are actually almost collinear. And then these are the parameters generated here. So the AUC is the one we're going to be interested in for bioavailability. So the bioavailability is just the dose adjusted ratio of the AUCs here. So if you plug in the numbers for the IV, that's the IV, and the oral AUCs and doses, then we get a bioavailability of 51%. So example 2 I was going to show. So certainly in the project I've been working on, when we get PK data done, the CRO calculates all of the PK parameters for us. On the other hand, when we're doing efficacy experiments, we don't get any, we just get the plasma values read out. And one thing you might be interested in is when you've got plasmas sampled from the efficacy experiment, how does the PK that you saw in the efficacy experiment compare with the PK that you got in your PK experiment? So this is a different compound. So we've got the IV and oral PK traces shown on the graph here, and then these are the PK parameters calculated from those plasma concentration time plots. And you can see we've got quite a long half-life, 10.5 hours, and oral bioavailability of 60%. In terms of the efficacy experiment, the way we've been doing them, we've got far fewer time points sampled, so you know, probably the values aren't going to be quite as precise. But if you plug this into the PK solver, then you get this set of parameters calculated on the right-hand side, and you can see that the half-life is very similar to the IV half-life in the PK. I should say the efficacy studies, as typical, is done at a much higher concentration. So the AUC is much larger, but when you do the dose-adjusted ratio, it now shows the bioavailability at about 25%, so somewhat lower than was obtained in the lower dose PK study. The final thing I wanted to show in terms of the use of the PK Solver add-in is the use of the Excel functions. So this is a list of the functions that are available from the paper. So you can see that to use them, you just put in, they all start PK underscore something. You just put in the appropriate function, and then they pretty well all start with the time range, and then the concentration range, and sometimes you need other parameters like how many points you're going to use to calculate the terminal slope and what the dose was. So in an example of this, actually our PK experiment involves 3 plasma concentration time courses for oral and IV dosing, and so we can calculate PK parameters from each of those. And I've just shown the calculation of a few parameters using the functions available in PK Solver. So this is one example. You can see it's just simply a matter of putting in the address of the time course and the concentration. In this case, I've also divided by 1,000 to get the AUC into micrograms per mil, hours times micrograms per mil rather than nanograms. One thing about the functions, it's not immediately apparent within the documentation that I can find as to how the AUC is calculated, but from what I can tell, it looks as though it's linear up and linear down. And as a check on that, I just did a very simple Excel calculation of the AUC for this plasma concentration series, and we get exactly the same values once you've adjusted for the nanograms and micrograms difference. Okay, a couple of other thoughts. So as I mentioned, PK Solver does have additional functionality. I'm not a PK expert, more a user, so other people, you may want to dive into some of the other functionality. Certainly compartmental analysis and calculation from infusion data are some of the things that the tool will also do. In terms of installation, I gave the installation information earlier on. One thing that caught me out the first time was that you need to have Solver installed as well as PK Solver, and those two are different things, so you do have to install them both. There's also, because PK Solver is an Excel add-in, fairly recently, I think the Microsoft has been, picking those as potentially dangerous files. So you may have to unblock the Excel add-in, and essentially it involves finding the file, which doesn't have to be stored anywhere special. You can point to it anywhere, but you may need to right-click on the properties and unblock that file for use. There's more information if you follow this link, which is the same as the longer version of it down the bottom here. The other thing, so hopefully having got you excited about the prospect of using this, I should warn you that I have had some intermittent issues with Excel crashing on closing in Windows 10. Not disastrous, it doesn't crash the machine or anything, but it's basically a sort of an inelegant end to your Excel session when you shut Excel down. So obviously it's prudent to make sure that you've saved all your work and don't rely on the closing the final Excel spreadsheet as a save route. And then before exiting Excel, if that does happen to you, you can go to the add-ins place. This is explained in more detail in the installation notes, but file options, add-ins, and hit the go button and unselect the PK solver. And also I found it necessary to change the extension of the PK solver XLA file and just rename it so that it's not picked up anymore as an XLA, and now it should close more elegantly. I just wanted to acknowledge a few people, obviously the authors of the tool themselves, who, as I mentioned, I haven't been able to get into contact with, unfortunately. David, who provides a nice place to download the files from, and also Nada and Gav for useful conversations. And also I should point you to Nada's paper here, where this is one of the examples of a paper that cites use of PK solver. This is a nice paper on schistosomiasis. Okay, so that's the end of the part on the PK solver. I was just going to go into some comments about where we are with the PK tool itself. I don't think I'll show the quick poll on people who'd used PK tool, but I'll just go through the, it's just got 3 slides on this, covering off the scientific enhancements that we want to bring into it, some usability enhancements, and also whether or not to transfer the source code from MATLAB, which is currently written in, to something else such as Python, which might be more readily available to people that might want to take the source and improve it. So hopefully you're somewhat familiar with the PK tool or aware of its existence. As I mentioned, there are other webinars in this series that you can look at. So the PK tool, so the PK solver is doing the job of taking raw data and calculating your PK properties for you. The PK tool is taking properties and also and scaling them up to human dose prediction, basically. And some of the enhancements that we want to make to it, it uses allometric scaling as one of the ways of doing this, and at the moment you're forced to use values for the parameters I'm showing there. In particular, I'm aware that some people prefer to use other values for clearance in particular, and we're intending to enable that in the next version of the PK tool. Also, dose prediction. Currently, I think this is one of the most popular ways of doing dose prediction to calculate a dose that will give you a efficacious concentration at trough. But we want to enable some additional ways of doing it. One of them, not least because quite a few projects in the space of neglected diseases are interested in single dose cures, and at the moment the calculation assumes that you are at steady state in a multi-dosing regimen. So it's going to enable a prediction for a single dose, and also instead of necessarily at looking at Cmin, we can base it on Cav and even Cmax. At the moment, the third scientific enhancement we want to introduce here is, at the moment, there is a correction if you use microsomal clearance. There's a correction for microsomal binding, but if you use hepatocytes, there's no similar correction for hepatocyte binding. So we'll introduce that. And bioavailability at the moment in the tool is assumed to be 1 unless you change it, so 100% unless you change it, and there's no real guidance on how you might do that. I guess the most obvious thing to do is just to use the same bioavailability as you've got in whatever your PK or efficacy model is, but there are other ways of doing that, and in fact Xenologic did propose a way of doing it, but never enabled it in the tool, so we propose to do that. And then finally, when we talked about this with people previously, there was a suggestion that we might actually include a prediction of microsomal and hepatocyte binding, a QSAR-based prediction based on log D or log P, and whether the compounds are the charge state of the compounds, basically. So those are some of the things that we want to introduce scientifically. And then the other enhancements are all about usability. I'm not going to go through this long list, but principally a couple of things we want to do. One is a sort of pet beef of mine. When you're using the tool, it forgets the folder that it was in last when it last imported or exported data. So we're going to fix that. And the other major thing is we're going to put a lot more tooltips in there, so that hopefully it'll be a bit more easy for people to understand what's going on. So the final thing I wanted to mention is that in doing the enhancements, we've also got the possibility, at least, of porting the tool from MATLAB to Python. So for those of you that aren't aware, MATLAB is essentially a commercial tool, and a lot of people do know it. It's very good at mathematical modeling, and makes tools fairly quick to put together. And also you can have a license to essentially generate standalone tools that don't require that the end users have a MATLAB license. So that's fine. That means that all of you, anybody, can use the PK tool as it currently stands. The only issue is really that in terms of taking the tool and making any changes to it, which is part of what we'd like to enable in the open source community, there are probably fewer people that have MATLAB licenses to enable them to do that. So we're considering the possibility of porting it to Python. So if anybody has any feelings about that, one way or the other, it'd be great to hear from you, now or by email. And I think that pretty much concludes what I wanted to say. So if anybody has any questions either about PK Solver or PK Tool enhancements, that would be great. Please fill them in the box or raise your hand electronically.
Thanks, Mark. That was great. So whilst people are writing their questions down, I had a quick question. Where do you find the documentation for the PK Solver Excel functions, and are they easily document? Are they easy, well explained or not?
No, I would say is the
Right.
They're not terribly well explained. They're in the paper. There is that list that I showed is in the paper, but they're not really explained. There isn't a list of each of them and a separate explanation of exactly what each of them is doing, though they follow the functionality. I guess that most of them are being used when the PK parameters are being calculated, and they give the same values under the same conditions. But the paper really is the place to go for the explanations of what the PK tool, PK Solver, is doing, as far as I can see.
Right. So you would recommend using the GUI front end rather than trying to do your own thing with the.
Well, it's perfectly. I think to a large extent, the fact that the list comes with a set of, it's relatively explained what it's doing. They're alongside the parameters that are being calculated here, and it tells you which data are required to generate those. I think it's perfectly reasonable to use these. I think it's pretty clear what's being generated. The only uncertainty I had at one point was this question over the AUC and whether that was being done in a linear or log sense. As far as I could tell, it was linear.
Right. Okay, we have a comment, I think, from Chris Swain, who says Python would be preferred. I'm quite willing to unmute Chris so he can. Oops. So he can talk to you.
Hello, can you hear me?
Yep.
Yeah, sure. Hi, Chris.
Hi there. I think my feeling is that most of the data analysis tools for a whole variety of things are moving more and more towards Python. Has a much bigger user base, and I think it would be. It sounds like an ideal thing to turn into a Jupyter notebook.
Right. Yeah. Thank you.
Do you have any other comments?
Not from me, I'm afraid.
Okay, I'll meet you again. Anybody else? Any opportunity for any last comments about anything that Mark's talked about, or any things that you feel might be improvements to the PK tool for those of you who use it? Tell you what, Mark, you could launch a poll now.
Yeah, I'm quite content.
You're quite content not to.
Yeah, I don't want to wrestle with the don't want to tempt fate with the technology.
Okay, well, if there are no more questions, thanks to everybody for attending, and look out for an announcement for next month's talk, which will be from Abhik Mukhopadhyay from the European PDB, who'll be talking about using protein structures and some of the facilities that the PDB produce to allow you to manipulate proteins in 3 dimensions.
I guess it's also worth saying, Caroline, just as a last thing, that also to look out for an email that you will get over the next few weeks that will ask you to positively identify yourself as someone who wants to remain on our mailing list. Otherwise, we will lose contact with you forever. If you don't know, it's part of the European GDPR process where everybody's getting a lot more hot on keeping personal information and how you use it. So there will be an email coming your way, and if you want to remain getting updates from us, then you'll need to say that you'd like that to happen. That will be great. Thanks.
Okay, thanks for that, Mark. Right, okay, thank you very much. Have a good rest of the day, wherever you are, and hope to speak to you soon.